Whoops.
No, it started. Okay, number 1, convert each degree measured to radians. Okay, well, I put it on my little circle up there, 315 degrees. I guess I didn't write the degrees part. 315 is 45 degrees short of 360, so it's 7 pi over 4. This part would probably be easier, quicker to look at those circles on page 259 than it would be to plug it in the calculator. Because these are like nice round numbers that have good answers. Okay, so they should be in the circle. B, 225, that's like 45 past 180. So that's going to be 5 pi over 4. C, 15 degrees. Well, I didn't put that one up there. 15 degrees is like 1/12 of 180, so it'll be pi over 12. That's, did they put that in the circles? No, they didn't. Okay, negative 45, so I don't know if you guys remember, we said 45 is like pi over 4, because it's a fourth of 180. So negative 45, you just put negative pi over 4. Okay, so let's say we didn't know how to convert 15 degrees. What's the converter?
Pi over 180.
Pi over 180, because the 180 will cancel out the degrees part. And 15 over 180, it would reduce to this. So you could plug that in your calculator. Do you guys calculators, if you plug in pi, does it leave pi in the answer?
Yeah.
Sometimes. Okay, it might depend on what mode you're in. But we do want to leave pi in the answer on these.
And if it did like just put pi into it, would you just divide by like 3.14 and then have that number and then put pi next to it?
I guess that sounds like a lot of work. I wouldn't do that now.
Okay.
If your calculator doesn't do it, I would just do this and then add pi to the answer.
Okay. Cool.
All right, 3a. So you could use the converter, negative 120 times pi over 180, or you guys know what fraction of 180 120 is?
2 pi.
It's 2/3. Yeah. So it's going to be negative 2/3 pi, or negative 2 pi over 3. Okay, B, 135. 135, I put it on the board.
Oh, this is.
It's 45 short of 180, so it's like 3/4.
Wrong B.
Yeah.
Oh, I did the wrong B.
Yeah.
It's
To negative 240. Alright, well, that's kind of double this one, I guess, because this one was negative 120. So if you do that times 2, negative 4 times pi. Times 2 over 1. 300 degrees. Well, that's 60 short of 360. 60 degrees is 1/3, so it's
5/3.
yeah, it's 5/3. Did you get that from the circle?
No.
Or how'd you do it?
Yeah. Circle.
You saw it in the circle.
I'm just
Okay, D 360. You guys should know this one by heart. 360 is how many radians? 2 pi. Not just 2. It's actually like, since pi is 3.14, it's actually like 6.28, roughly. So, yeah. In radians, or in pi version, it's 2 pi. In decimal version, it's 6.28. All right, number 5. Same thing but backwards. So we're going from radians 2 degrees. You guys remember what pi over 2 was for number 5? Basically, I know I said a converter earlier, but here's an easier way to convert these. Pi just turns into 180. So it's like negative 180 divided by 2. So it's negative 90. Okay, so pi is just worth 180. So it's like 180 divided by 2, so it's negative 90. That's probably the easier way to convert radians. But if they don't have like the pi, you can always just use that 180 over pi thing. B, 4/3 pi. What's 4/3 of 180? So it's kind of like 4 times 180 over 3 is 240. I'm going kind of fast. Are you guys following this? Okay. No, I guess you know this later. C, negative 3/4. I don't know if you guys remember, 3/4 was 135. So, negative 135. Pi over 6 is, that was 30. It'd be like 180 divided by 6. So this is going to be negative 30 degrees. I smell food. Yeah.
Oh, Mr. Jones done.
No one
Thought you were gonna go find food.
Yeah, I'm just going to wander off.
Yeah.
Smell food.
Pull a Mr. Smith. That's it, Mr.
Mr.
Smith. He would
No, he doesn't go.
Mr.
He'd go for
Mr.
coffee.
Smith would have never said
Then
anything.
what would
He
you would just left, yeah. Didn't lecture.
Pretty sure he did that one.
He does that, yeah.
When they brought coffee in for the
She's got a need
teachers,
for coffee.
He just walked out of the other classroom.
You abandoned us. Okay, 7a. Pi is worth.
180.
Nailed it, Leo.
I didn't look on the graph either.
Nice.
I watched him walk out of the classroom and he had the biggest smile on his face.
Okay, 3/2 pi. I don't know if you guys remember that one. Was put that one on here.
270.
Yeah. So, but it was negative, so we gotta put negative. Don't forget the negative. We have to count them off. Negative. These are only gonna be a half point each. So. C. 2/3 of 180. 120. D. 7/6. 7/6 of 180. Okay, we didn't talk about this one, but it's kind of basic. I suspect this is why they made up radians instead of degrees, because it helps with make the formula easier for the arc length. You guys remember arc length from last year?
Could you remind me?
Okay, if you draw a little pi piece on a circle, the piece of pi is called a sector. And the arcs are like the pieces of the circle, like crust, I guess. So the sector has an area, and arcs have lengths. And the arc length is like a fraction of the what? What's this called?
Oh no.
Huh? Somebody say it. What'd you say?
Crust.
Like if I was finding the length around the circle, what would it be called?
The area?
Circumference. Circumference.
No.
What'd you say?
I didn't say it yet.
Oh no. We just triggered Sam.
Stop it, Leo.
Let's get into
No, I won't.
It'll be so respected.
No, I
It'll
won't.
be on YouTube.
No,
Say it.
You'll be
I will not.
immortalized.
It will start now. I will not.
Don't give in to temptation, Sam. Don't give in to the dark side.
I will not.
Anyway, the arc length is a fraction of the circumference. So you guys remember the circumference formula? 2 r pi or diameter, no, pi r squared is circle area.
Okay.
That's circumference, and then you just do that times whatever fraction of the circle you're using, where theta is like this angle right here. Okay, but if it's in radians, the formula is a lot easier. This simplifies a little bit, but the radians formula is a lot easier. You just do the radius times the angle equals arc length. You guys remember theta? Everybody's favorite variable? This is what I'm saying, theta. It's Greek. Okay, anyway, if theta is in radians, you just do theta times the radius. Probably why they call it radians, because... Anyways, yeah, we just multiply this together. So on number 9, you just give the radian measure. Oh. Okay, they're giving us the arc length, not the radius, or not the theta. So, if radius times theta equals, they're calling the arc length S for some reason. How do we solve this for theta? If we divide by r, yeah. So, on 9 we're going to have to do the arc length divided by the radius. So it's just 6 divided by 5. Yeah, they put 1.2. But I would accept 6/5. So B 6 divided by 8. You guys know what that one is?
3/4.
Yeah. 4.75. So 10's kind of the same, but they're missing theta, but you still have to do the arc length divided by the radius instead of the arc length divided. Oh no, that's the same thing, my bad.
Same thing?
Yes. Thought they switched to variable.
Sounds like chili.
Small pancakes.
Okay, on 11, we have to use the formula. Why do we have to use the formula?
Last one.
You guys know why we have to use the formula on 11? We're converting from degrees to radians, rounding to the hundredths place. Okay, because there's nothing special about 95 degrees. It's not like 90 or 180. It's not a special angle. So it doesn't work out nicely. So we are going to use our calculators. Do you guys remember what the conversion was? Converter? Pi over 180. Okay, this time we do want decimal, and we're going 2 decimal places.
What?
1.66. Do round correctly. I don't know how many times you guys have screwed up your rounding jobs. It's been a lot.
Sorry.
You're big kids now. You should round correctly. Okay. B is the same thing. We need to talk about C, I guess.
What degrees in minutes?
Yeah, I can't believe you guys remember, or Sam remembered it at least.
I learned how to drink now.
Well, we did I mentioned it last year. Minutes. Well, do you know what a minute is?
60 seconds.
It's 1/60th of a degree, just like a minute's 1/60th of an hour. So this is like 95 and 10/60ths of a degree. Okay, so this 10, they're called minutes, it's a fraction of a degree. It's 10 out of 60 of a degree, 10/60, like 1/6. So when you do your converter, you just need to change it to a fraction. So it's that times pi over 180. Or you could do 95 and 1/6 times pi over 180.
I got 0.28.
No,
I got 1.66.
1.66 again. It's close enough to A that it's slightly larger than A, but it's close enough that it rounds to the same thing.
Mr. John, what did I plug it on?
Did you just write a fraction next to 95 instead of
Yeah.
putting it as a mixed number? They might have multiplied that together, probably. And you don't want it to be multiplied. It's more like adding, but just put it in as you know how to put it in as a mixed number?
No, not on a calculator. I usually just put it next to each other.
Okay, it's just right above the fraction button.
Okay,
So you just said shift.
got it.
It looks similar to what you wrote, or what you pressed. Okay, no tricks on D's, so just plug it in normally. 13, they said they want the answer in decimal and minute form, but I don't think minute form's worth it. It'll confuse you guys, and it's not as efficient as decimal, so
13 or 14 on minute form.
you can just do decimal form only, it's fine. So on 13A, it says 1.6. There's a couple reasons we know these are radians. Number one, they did not put the degree symbol. Number two, you're probably not going to have a 1.6 degree angle. Number three, the directions told us. But we're going to convert these radians, 1.6, so that's like, it should be really close to 90 because 3.14 is equal to 180.
1.68.
So to convert, we're going to multiply in the degrees and divide out the radians. So that's the converter. And it says round to the 10th place.
Please.
That's not me, Sam.
0.7.
91.7.
You just think it's right.
E.
Why would you even think it's not? It's crazy.
For some reason B, they just changed it slightly. If you did have to change it to minutes, you'd have to do 0.7 times 60, but we're not gonna do that. 96.4, 7.4, yeah, that's right. Okay, C, 1.21, I don't know, there's nothing special about these. Six, 9.3.
Are we doing 15 or 16?
Yeah.
I guess.
We're not gonna measure with the protractor now.
It says estimate.
We're gonna guesstimate.
I guess 35 degrees and 93 degrees.
We're supposed to do it in radians though.
Well then, 35 times the
Okay, so on 15, yeah, let's start with degrees. Like, how many degrees do you guys think 15 is?
35.
Probably about 30, I'm gonna guess. And what fraction of 180 is 30 degrees? 30 degrees is what fraction of 180?
Pi over 6. Never mind. Pi over
30 of 180 is
1/6.
1/6. 3 and 18 reduced basically to 1/6. Anyway, so pi radians is 3.14. So this should be 1/6 of about 3. So what's 1/6 of 3? About. We don't have to be exact. What's 3 divided by 6? 0.5. So, yeah. 16 is easier because it's slightly more than 90 degrees, so it should be slightly more than half of 3.14. You just have to get in the ballpark. It just says guess to me. Okay, 17. It actually gets kind of easy on 17. Well, the whole thing's been easy.
Just jinxed it.
Yeah. So it says find two angles, one positive, one negative, that are coterminal with each given angle. You guys remember what I said coterminal meant? No, it does not mean cancer.
Oh, it's the same place.
They stop at the same spot. So, we need two angles, one positive and one negative, would stop at the same spot as 500. How was I doing that at the beginning? Finding the same place? Okay, you just go around the circle 360 degrees and it'll stop at the same spot. So if we go backwards 360, it should still be positive. You could also do plus 360. If I back up 360, I get 140. So that should stop at the same spot.
So do you need to find 2 points?
Yes, if I do 140 and back up another 360, go and reverse another 360, I'll get negative 220. That's a negative.
So does it say need a negative? Okay.
You need one negative, one positive. So you can add 360 or subtract 360 as many times you want. And there are multiple possible answers on this. So negative 60, so how would I turn that into a positive coterminal angle? If I add 360, I'll get a 300 degree angle. And to get a negative angle, I'll subtract. Okay. C says pi over 4, so in other words, we probably should stick to radians. So instead of adding 360, what am I going to add?
2 pi.
2 pi. Now, okay, if you don't really need to plug the pi in the calculator. You could just plug in like 1/4 plus 2, which is 2 1/4, which is like 9/4. So some of your calculators might spit that out, or if not, you could just do this. Your calculator should spit out. Well, it might say 2 1/4. I don't know, which is correct, I guess. Pi over 4 minus 2 pi would be like negative. So it's like 1/4 minus 2, which is like 1/4 minus 8/4. It's negative 7/4.
Where'd you get the 2 pi?
Okay, so coterminal is like adding 360, it'll go around the circle and stop at the same spot. So on radians, 360 is the same as 2 pi. So you just do the same thing as A and B, but use 2 pi instead. D, negative 2 pi over 3. So this is kind of like 2 minus 2/3, or 6/3 minus 2/3 is 4/3. And to get my negative version, subtract 2 pi. So it's like negative 2 2/3, which is negative 8/3. I don't know if you guys remember converting mixed numbers to improper, you multiply by 2. There are buttons on your calculator that can do it automatically. I'm not gonna count it wrong if you put a mixed number either. Wait, did that? There was no E. Okay, 19, same thing with decimals. I think 18's enough.
Really? Oh.
Yeah.